Hello, my name is Mona Sheikh. I'm going to present the cholesterol treatment study. I'm sorry. So I'm going to start first giving a brief summary of the study or the study objective methodology. So the study objective is to identify factors that might decrease overall level cholesterol. And the second objective or the second research question is there any association between BMI and total cholesterol level? Our methodology is this. The study type is experimental study, and the study subjects were divided into three groups. The first group labeled as a group 0, they were the control group receiving no treatment. The second group labeled as a group 1, and they received treatment A. The third group labeled as a group 2 and received treatment B. Statistically, in order to analyze our study results, we used SPSS and we ran one-way ANOVA test. And the reason we selected one-way ANOVA because we have one dependent variable, which is quantitative type of variable, and we did have three groups. Given that we have three groups, that means we need to run ANOVA test in order to avoid the family-wise error or multiple error. And we can't use t-test because t-test it requires only 2 samples. And the other analysis that we run in order to answer the second research question is regression. And the reason we selected regression is the same reason, because we have more than 2 samples, and we are comparing 2 quantitative variables, which is the BMI, given it is quantitative, as well as cholesterol is quantitative. And the fact is we have a 3 sample group, which is group 0, group 1, and group 2. And if we go into the result of the study, after we ran the data analysis through SPSS, so we came to answer, in order to answer the first question, which is if there is any significant difference between the means of the 3 groups using statistical analysis one-way ANOVA. After we ran our analysis through SPSS, we have these outputs. The first output that we have is the descriptive. Here, as we see on the first table, is here we can see the 3 groups of the study subjects: group 0, which is a control group, group 1 receiving treatment A, and group 2 receiving treatment B. And the sample size of the 3 groups is equal, 30 in each group. And then here we do see the mean of the cholesterol level in each group. As we can see here, the group 0, which is the control group, has the highest mean level of cholesterol when compared to treatment B, which has the lowest level, and the group 1 came the second level, 196. And looking into the standard deviation, which tell us the deviation of the variability within the group itself, group 0 seems to have the lowest standard deviation, 14.37, and the group 2 seems to have the highest level, which is 15.6, and the group 1 just next to, I think it's about the same or just close to group 2, which is 15.1. And here on this descriptive analysis, we have as well confidence interval, the 95%. We do have here the standard error, as well as the minimum and the maximum level of cholesterol in each group. As you can see here, group 0 seems to have the highest level of cholesterol since they were not receiving any treatment. They were the control group. And group 2 seems to be the lowest level, from 149 to 222. And the confidence interval, the 95%, it seems to be here, the group 0, the highest level, and the group 2 is the lowest level. And here it gives us two robust test of equality of mean. It's a good way to support the means analysis. And here, testing of homogeneity of variance. Here it gives us, like, because in null hypothesis, we hypothesized at the beginning that all means are equal. Here we are testing if that fact is true, test saying that the three groups were homogeneous or their means were homogeneous. So in order to answer that question, we look into significance level here. This column is the most important one. Looking here, we can see here all through the significance level is 0.7 here, 0.8 in the other three. All are insignificant. That means we are rejecting the homogeneity fact, and we can say the three means are not homogeneous. And here we are doing the comparison between the groups using graphs. Looking here first into the box plot, we can see here the group 0 has the highest cholesterol level and the group 2 highest the lowest level. However, group 1 overlaps with group 2, and we can see here the mean here and the mean here are very close, while the control group is the highest, which is the same as we saw earlier. The group 2 and group 1, the mean were close, like 193 and 196. However, the control group were 222. And through this graph, we can see here the control group, which is the 0, the cholesterol level went up here very high. Then when compared to the group 0, the cholesterol level dropped. And then it kept dropping a little bit further down in group 2. So from the descriptive here to the graph, we can say the treatment group 2 has the lowest cholesterol level. Then after that, group 1 will come on the second level, and the control group has the highest level of cholesterol level. Then here we run the ANOVA in order to see if there is a significant difference between the means, between the three means in general. And we look here into the b-value, which is tells us the significance level. And here we can see the b-value is less than 0.01. That means this is a strong evidence against the null hypothesis, which claims there is no difference between the three groups. Here, after running the ANOVA test, we can say confidently that null hypothesis is wrong and we can reject it. And we can conclude or state that there is statistical difference between the three groups. And also ANOVA table gives us the F statistical level 32 that support the rejecting the null hypothesis. And here we can see the variance between the groups within, like between the groups and within the group and the total. However, if we want to, the ANOVA gives us the significance difference between the group in general. However, if we want to test the difference between like group 0 to 1, 1 to 2, we run the test called post-hoc test, and it gives us this result. If we look here, if we do a comparison between group 0, which is the control group, compared to group 1, we can see here there is a significant statistical difference, given that the b-value here less than 0.01. And when group 0 compared to group 2 was the same as well, there's a significant difference between the two. And here we are comparing group 1, group 0, and 2. So when it was compared to group 0, there was a significant difference as well between the two. However, when 1 compared to 2, there was no significant difference because here the b-value is 0.3, which is the higher than 0.05. In alpha is at 0.05. And here we are comparing using LSC. We are comparing group 2 to group 0, and there is a huge difference. It's a statistical significance difference between the two, given that the b-value is 0.01. However, when the comparing done group 2 to group 1, again, there is no significant difference between the two. So we can say here, group 0 comparing to group 1 is different, and when 2 compared to 0 is different. However, when 1 compared to 2, there is no significant difference. Okay, in order to answer the second research question, if there is any association between the BMI and cholesterol level, we did the regression analysis, and I mentioned earlier the reason that we selected regression, because we do have the 3 sample tests, which is the 3 group that we have, the group 0, group 1, and group 2. So we need to select a test that gives us the ability to assess multiple means, which is regression. And the reason we selected with regression, the other reason is because we are comparing two quantitative variables, which is the BMI and cholesterol. So after we did our analysis, and the SPSS gave us this result, and looking first into the significance level here. So the significance level here is 0.98, means this is higher than 0.05. That's mean the association or the claiming that there is an association between the two, which is the null hypothesis. It's we can't. There is no. We can't claim that. So we should reject that, and that means there is no association between the two. And here we do have the F statistic level, given that's 2.7. That's it's not a very big number, because the F will be more significant as it becomes larger. And here, if we look into the correlation, the SPS run another correlation, which is the Pearson correlation. And the results here, if we see, for cholesterol is 0.17, and here it's 0.049, which is very weak association or correlation between the BMI and the cholesterol level. And if we look here into the most important coefficients, and we can look here, the unstandardized the B, which is the intercept. Here it means if the BMI goes up 1.89, there will be a percentage increase in cholesterol level. And the opposite is true. If the BMI goes down 1.089, there will be a decrease in cholesterol level. However, if we look into see if this correlation is really statistically significant, if you look here, we have 0.98. That means this analysis or the association between the two is not statistically significant. And the other thing is here, the confidence interval between the two, it does contain 0, because it runs from -207 to 2.38. That means between these two numbers, we have a 0 in the middle. That means this thing is not statistically significant, and we should reject the null hypothesis here. I mean, we should retain the null hypothesis. We can't reject it. I'm sorry, we retain the null hypothesis. And also here, we are showing the regression on a scatter plot, and we can see here the regression line is not sloping upward or downward.